Okay, we covered what information we needed to discern what process to use, and we introduced the T distribution in our discussion, but now we need to figure out how does it play within this information we're going to learn. So we're going to start first with an example of the fact that a student T distribution has a mean of T equals 0 and a standard deviation dependent on the sample size greater than 1. It has to have at least two elements. How to read a T interval is our first example. So here we have a display from a sample of airport data speeds in Mbps's. And it reads the interval 13 and 46 thousandths to 22 and 1500ths. X bar, and I didn't type the bar in, sorry about that, 17 and 598 thousandths. The sample standard deviation is 16, and that very long number, which we're going to say is 16 and 200ths. And the number, the N of the sample is 50. And that's with a degree of freedom. Okay, so now we want to work this problem. And first off, it says express the confidence interval round to 2 decimals. So our interval is 13 and 05, comma, 22 and 15. Identify the best point estimate of mu. Well, we know that this is p hat over n, and that guy is our x bar, 17, and we're going to do 2 decimals. The margin of error. Okay, here's our first formula. What you're hearing is my dog Sadie eating her food loudly. Sorry. So for the margin of error, or the rule of thumb for margin of error, we use the interval, and we want the high minus the low divided by 2. And that'll give us the margin of error. So what does that give us? It gives us 22 and 1500ths minus the 13 and 500ths divided by 2. When we do this math, we're going to get, let's see what my calculator says. I'm not going to make a mistake over simple math. And we're going to do the 22 and 15 minus the 1305. And I get 9.1. Divided by 2, which gives us the 455 is our margin of error. And we would say that our E is 4 and 5500ths PS, because we have to label that it is in consistency with the speed of data speeds at the airport. In constructing a confidence interval for mu, why is it necessary to confirm the sample data appears to be from a population with normal distribution? That's our question. Okay, so what we're looking here is to analyze. This is our first analyze. So we're going to, we draw from what we have. We have a size of sample to be 50. So that tells us that we have n greater than 30. All right. Then we have a sample mean of a normal distribution because of the size of the data set. Remember the requirement that they be random and that they be either normally distributed by statement or n is greater than 30. All right. What is the number of degrees of freedom that should be used to find the critical value t of t sub a alpha divided by 2? Well, it would be the 50 minus the 1. So 49 is the degree of freedom. And remember, we did this before when we do a sample set. Even though we use the calculator, the sample set says you have to have a play, a one less than the sample set to give you a play of all the anomalies that could happen from another sample. So now we're looking at find the critical value of this value. All right. So we're going to use our calculator. Okay. And to find the critical t, I wrote it down here. We go second Var's distribution, choose the menu for inverse t, and understand that the confidence level plus alpha divided by 2 is a critical area. So we have 95. So alpha equals 1 minus 0.95, which gives me alpha equals 0.05. Now, alpha divided by 2 is 0.25. Therefore, our confidence level is 0.95 plus 0.025, which gives us 0.975. All right. So now we know that this is our confidence level or area that we're going to be needing, the area. So now we're going to use our calculator. Let me get it back up. Where did it go? There it is. And we're going to go just like the statement, second Var's distribution, and see inverse t because we want the t. So I'm going to go 4. I'm going to put the decimal 975 for the area, and degrees of freedom we said was 49, and we enter. And we want to round to 2 decimal places. So the t alpha divided by 2 is 2.00. All right, is everybody comfortable with that? I think it was 2.00. Let me look back at my calculator. Oh, I'm sorry, 2.01. That's what I get for not copying it down on the page, but I will. All right. Give a brief general description of the number of degrees of freedom. All right. So the number of degrees of freedom from the sample data is a number of sample values that can vary. So the degrees from the sample data, so I forgot data, is the number, because you can have more than one, but for our text, we're only using one. And that's usually the standard. As you get into advanced statistics, you'll understand the use of the others. Is the number of values that can vary after certain restrictions. And here they're talking about outliers, anomalies, things that have been imposed on the data. By decree. Well, this one example gives us all the lesson. I'm going to stop right here and we'll start up with example 2 on the next video.